All right, Math 2 students, my goal for this video is to help you understand how to multiply binomials in two special cases. One special case is called the binomial squared pattern, and the other special case is called the sum and difference pattern. As we go through the video, pay attention to both patterns and how they are different so that you don't get them confused.
The first special product that we're going to look at is the binomial squared pattern. So I have four examples for you, and they're all binomials times binomials. So we're multiplying a pair of binomials together. But what makes this fit into the binomial squared pattern is that in every example, we're multiplying a binomial times itself. So our normal mathematical convention is not to write x plus 4 times x plus 4. Instead of repeating it twice, we would just write it x plus 4 squared, or the quantity x plus 4 to the second power. So on the next one, instead of writing x minus 3 and x minus 3, we'll write the quantity x minus 3 squared. On the third one, instead of writing 2x plus 1 times 2x plus 1, we would write 2x plus 1 squared. And finally, on the last one, the way we would write it is x squared plus 4 squared. So now we're going to actually do this problem. If we're going to multiply x plus 4 times x plus 4, then we need an x plus 4 on this part of our table, and we need an x plus 4 on that part of our table. When we multiply in our first example, we'll get x times x is x squared, x times 4 is 4x, x times 4 is 4x, and positive 4 times positive 4 is positive 16. On our second example, we'll have x squared, we'll have a pair of negative 3x's and a positive 9. On our third example, we'll have 4x squared, a pair of positive 2x's, and a positive 1. And on our last example, we'll have x to the fourth, a pair of 4x squareds, and a 16. So the first thing that you should notice about this pattern is every table has a definite pattern that jumps out at you. And that pattern should be that the 4x and the 4x are exactly the same. The negative 3x and the negative 3x are exactly the same. The 2x and the 2x are the same. And the 4x squared and the 4x squared are exactly the same. So in a binomial squared pattern, you will always get two terms that are exactly the same. So the way they talk about it in math books is a little confusing sometimes, but basically if we look at the first term, which on our first example, our first term would be the x, the beginning of your answer is the first term squared. The final part of our answer is the last term squared. And so our last term would be the 4. So when we do our first term squared, that's where the x squared comes from. The last term squared, 4 squared is 16. That's where the 16 comes from. And then the middle terms, it's 2 times the first term times the last term. So it's 2 4x's. So that would be 8x. So again, on our first example, our first term squared gives us x squared. Our last term squared gives us a positive 16. And our middle term is going to be the first term, which is the x, times the last term, which is the 4. So that's 4x. And since we have two of them, it's 2 times 4x, or 8x. And so that is the answer for our first example. In this example, we have the first term squared, which is x squared. We have our last term, which is negative 3 squared, which is positive 9. And then we have 2 of our middle terms, or 2 negative 3x's. So that makes 2 times negative 3 times x is negative 6x. And that would be the answer to our second example. If we just look here at the problem, here's our first term. And so if we square that, we're going to get 4x squared. Here's our last term. It's a 1. If we square that, we're going to get 1, positive 1. And then we have those two 2x's, so that's going to make plus 4x. And that would be the answer to our third problem. And then finally, we have x to the fourth plus 8x squared plus 16. And that would be the answer to our fourth example. So the reason that we're learning the binomial squared pattern is to speed up the process of finding the answer. This is something you'll have to do many times. Also, when we're doing factoring later on, the better you understand the binomial square pattern, the better you'll be able to factor. So the first thing we're going to get out of the way is the most common wrong answer. Many students look at this problem and write down 9x squared plus 4. And that is the wrong answer. As you can see on the previous 4 examples, every answer was a trinomial. And so this problem is going to have an answer that's a trinomial. So you do not want to write down the common wrong answer. So what's our first term squared? 3x squared times 3x squared is 9x to the fourth. What is our last term squared? Negative 2 times negative 2 is positive 4. And then 2 times our first and last. So our first and our last times 2. So we have 2 times our first times our last. And so that's going to be negative 6x squared, negative 12x squared. So on this problem, when we put it in standard form, our answer is 9x to the fourth minus 12x squared plus 4. On this problem, we have the common wrong answer. The common wrong answer is x squared plus 1. People just square the terms inside the parentheses, but that's a binomial, and we know from our experience so far that these answers will be trinomials. So what's our first term squared? It's x squared. What's our last term squared? It's 1. But the middle term is our first term times our last term times 2. So that's going to give us a 2x. And so our final answer on this problem would be x squared plus 2x plus 1. Now you could use a table to multiply this out, but we're hoping to learn how to do it more quickly and understand more of it in our head and less of it concretely on the paper if possible. All right, on this problem, the common wrong answer, 25x squared plus 49. That is not the right answer. In the binomial squared pattern, your answer is always a trinomial. But the first term squared is 25x squared. The last term squared is 49. And to find the middle term, it would be 35x. And that's what I get when I multiply the first and the last. But there's 2 of them, because if you remember back to when we were using a table, 2 of the boxes on the table were filled up with the same exact thing. So 35 times 2 is 70x. And so our answer on this problem would be 25x squared plus 70x plus 49. Our second special product pattern is the sum and difference pattern. This looks very similar to what we were just doing, except now instead of having 2 binomials that are exactly the same and calling it the binomial squared pattern, now we can't use the squared symbol because we're not multiplying something by itself. Here, we're multiplying a sum and a difference, an adding problem and a subtracting problem. So in each example, they look exactly the same, except for the last term is positive in one set of parentheses, and the last term is negative in the other set of parentheses. So we have one binomial with a positive sign joining the first and last term, and we have one binomial with a negative sign joining the first and last term. So this is called a sum and difference pattern. So now, when we go through, I've taken my x plus 4 and I put it on the bottom of the table, and my x minus 4 and I put it on the left side of the table. So now we're going to multiply and fill in all the squares and see if we can find the pattern. All right, so on our first example, we have x squared minus 4x squared plus 4x squared minus 16. On our second example, we have x squared minus 3x squared plus minus 3x plus 3x minus 9. On our third example, we have 4x squared minus 2x plus 2x minus 1, x to the fourth minus 4x squared plus 4x squared minus 16. And now, do you see a pattern? There should be a pattern that jumps out at you quickly. We have opposites in the boxes where we used to have terms that were the same. We have opposites in the boxes where we used to have terms that were the same. So in the sum and difference pattern, our answer is only going to be a binomial. We'll have the first term squared, that's where our x squared is here, and we'll have our last term squared, that's where our 16 is right there. But we will always have a minus sign in between because that 16 is the product of a negative and a positive. Here the 9 is a product of a negative and a positive. The 1 is a product of a negative and a positive. The 16 is a product of a negative and a positive. So our answers, x squared minus 16, because the negative 4x and positive 4x add up to 0. X squared minus 9, because the negative 3x and the positive 3x add up to 0. 4x squared minus 1. And x to the fourth minus 16. Notice that the product of the sum and differences, it always comes out to a binomial, and there's always a negative sign in between. Once you recognize that this is a sum and difference pattern, and you've memorized that that's going to be a binomial, and in your binomial, your second term is always going to be negative, we look at our first term squared, so 3x squared squared is 9x to the fourth. Our middle term is always going to be 0 on a sum and difference pattern. And our last term is going to be 2 squared, which is 4. So our final answer is 9x to the fourth minus 4. In this example, we know that it's a sum and difference pattern, which is x squared. We take the middle term, which is always going to be 0 in a sum and difference pattern, and we take the last term and square it, and that's going to be 1, negative 1. And so we have x squared minus 1, and that is the answer to this problem. Okay, once again, sum and difference pattern, 25x squared, or 5x squared is 25x squared. Our middle term will always be 0, and we have negative 49. So we have 25x squared minus 49, and that is our answer. For practice, try this example of the binomial squared pattern. Now, for practice, try this example of the sum and difference pattern.